Welcome. Today we'll learn how to analyze and interpret medical test results using statistical methods. We'll cover important concepts like sensitivity, specificity, and predictive values. Let's start with an example. Imagine we have a test for a disease and we've tested 1,000 people. We can organize our results in what's called a contingency table or 2 by 2 table. The columns represent whether people actually have the disease or not, and the rows represent whether they tested positive or negative. Let's understand what each cell means. In the top left, we have 100 true positives, people who have the disease and tested positive. Top right shows 50 false positives, people who don't have the disease but tested positive. Bottom left shows 10 false negatives, people who have the disease but tested negative. And bottom right shows 840 true negatives, people who don't have the disease and tested negative. Now, let's calculate sensitivity. Sensitivity is the probability that a person with the disease will test positive. It's calculated as true positives divided by all people with the disease. In our example, that's 100 divided by 100 plus 10, which equals 0.91 or 91%. This means our test correctly identifies 91% of people who have the disease. Next is specificity. Specificity is the probability that a person without the disease will test negative. It's calculated as true negatives divided by all people without the disease. Here, that's 840 divided by 840 plus 50, which equals 0.94 or 94%. This means our test correctly identifies 94% of people who don't have the disease. Now, for positive predictive value, or PPV, PPV is the probability that a person who tests positive actually has the disease. It's calculated as true positives divided by all positive tests. In our case, that's 100 divided by 100 plus 50, which equals 0.67 or 67%. This means if someone tests positive, there's a 67% chance they actually have the disease. Finally, let's calculate negative predictive value, or NPV. NPV is the probability that a person who tests negative truly doesn't have the disease. It's calculated as true negatives divided by all negative tests. Here, that's 840 divided by 840 plus 10, which equals 0.99 or 99%. This means if someone tests negative, there's a 99% chance they truly don't have the disease. Let's summarize what we've learned. Our test has 91% sensitivity, good at detecting disease when present 94% specificity, good at ruling out disease when absent 67% positive predictive value, moderate confidence in positive results, 99% negative predictive value, very high confidence in negative results. This means our test is particularly good at ruling out disease, but positive results should be confirmed with additional testing.